All right, howdy everyone. We're going to calculate some limits with limit laws. And as a quick recap, remember if the limit of f of x is L and the limit of g of x is m, then, well, you can calculate limits just the way you think you can as long as you avoid division by zero. First of all, constants, and constants only, pull outside of limits, so the k comes out and you just get the limit of f, which is L. Next, the limit of a sum is the sum of the limits. You take the limit of the first part and the second part, and therefore get L plus m. And the limit of a product is the product of the limits, so the limit hits the first part and the second part, giving you L times m. And the limit of a quotient is the quotient of the limits, so it hits the top, hits the bottom, and just gives you L over m. Of course, this is only legal if all the denominators are not zero near a and at a. Well, near a. All right. Let's do an example. So suppose we know that the limit of f as x goes to 4 is 2, and the limit of g as x goes to 4 is 3. Then we want to evaluate this sort of crazy long expression over here. So it looks very complicated, but in fact, you can break it up into its pieces because it breaks up sums. All these sums will be broken up, and it breaks up products, and constants pull out. So the limit is just going to hit the f here, and it's going to hit the g there, and the f and the g there, and then the f and the g there. Okay? So, right. What you get is that this first f is converging to 2. This g is converging to 3. The f is converging to 2. The g is converging to a 3. The f up here is converging to 2. The g here is converging to 3. So, you can see the answer will just be 5 times 2 plus a 3 plus a 2 times a 2 times a 3 plus a 3 times 2 all over 3. So I guess we get a 10 plus a 3, and a 4 times 3 is a 12. And of course, these guys cancel, so we end up with just a 2 there. So we get 13 plus 12, so that's 25, and another 2 is 27. All right, so that's the answer. Ciao.